In this video, we will cover a brief history of rocket flight. The main principles behind rocket and jet motors can be traced back to the Hero steam engine. Invented by Hero of Alexandria in the early years of the first millennium, the engine was a water-filled sphere. When heat was applied, the sphere would spin along its axis as steam escaped through the tubes attached to it. Rockets using gunpowder were invented by the Chinese sometime around 1232 AD. These early rockets were developed as weapons. Galileo Galilei was known for many accomplishments, including reigniting the flame of scientific discovery. His proof of the theory that an object in motion does not need a continuous force applied to it paved the way for the laws of Sir Isaac Newton. Newton condensed rocket science into 3 laws of motion. Every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. The relationship between an object's mass m, its acceleration a, and the applied force F is F equals ma. For every action, there is an equal and opposite reaction. We are demonstrating this third law using a Newton's cradle. Notice that we get the same number of balls rising from the cradle as we let go. Writer Jules Verne sparked the imagination of those dreaming of space travel. His book, From the Earth to the Moon and Round the Moon, describes a fictional shot to the moon by a crew of 3 from a cannon. Although it is not possible for such a means of transportation to the moon, he did describe the journey with prescient detail, such as picking Florida for the launch site. In 1903, Russian scientist Konstantin Tsiolkovsky based his theories of human spaceflight on Newton's second law of motion. Tsiolkovsky envisioned rocket flights using liquid fuel, as well as orbital space stations and solar system colonization. Considered the father of modern rocketry, American Robert Goddard built the first liquid-propelled rocket and flew it on March 16, 1926. Goddard's first rocket flight only reached an altitude of 12.5 meters. However, his work would lead the way to great liquid-fuel rockets that would take people into space. The late 1930s saw the V-2 rockets developed in Germany, led by Wernher von Braun. Von Braun would later become instrumental in the Apollo program that would send humans to the moon. The Cold War between the Soviet Union and the United States following the Second World War brought about a race into space between the two nations. Sputnik 1, launched by the Soviet Union, became the world's first artificial satellite. Human flights into space followed, culminating into the landing on the moon in 1969. The massive Saturn V rocket was the vehicle to do the job. NASA's Space Shuttle program began in 1981 and would continue until 2011. The Space Shuttle was made up of a glider-style orbiter with liquid fuel-propelled rocket motors. Fuel for the motors was provided through the large tank the orbiter was attached to. Large solid-fuel rocket boosters at the sides of the tank provided much of the initial power for the Space Shuttle. In 2003, China became the 3rd country to send humans into space. The Chinese Shenzhou spacecraft, based on the Russian Soyuz, was launched into space aboard China's Long March rocket. With the retirement of the Space Shuttle program, a lot of focus has been placed on private firms to build and launch rockets. With the goal of improving efficiency, we may be looking to a future of more frequent rocket flights into space. For more information on this as well as other aerospace-related topics, please visit us at www.sigmarockets.com.